Hello, Chemistry 11. This is Mr. Chan. And today what I wanted to do with regards to stoichiometry is talk about something called limiting factor. Now, last day in our lessons, when we did the stoichiometry, when you did the examples, and hopefully, you folks did some examples, what you could do is if you took a look, it was always, you had, let me see here, you would have one substance and you would calculate the products. Or you were given one substance and you were asked to find the other reactant, as in this example here. Now, this is not always the case. So when we talk about limiting factor, what this is when we have, in these types of problems, we have two, or in this case, two or more amounts of reactants are given to determine the maximum amount of products that can be made. Because two or more reactants are given, one is always in excess and the other will be completely used up. The reactant that is used up is called the limiting factor, and this determines how much product can be made. Now, let me give you an example here. So if I were to show you something like this simulation. So let's say we're making a sandwich, okay? Now, let's make a meat and cheese. Now, if you look up here, it says you have 2 bread plus 1 meat plus 1 cheese gives you a sandwich. So what do I mean by limiting factor would be like, let's say we were given 8 slices of cheese, we were given 3 pieces of meat, and let's say we were given 4 slices of cheese. Now, notice the amount of sandwiches that we can make was 3. Because, and the reason why it's 3 is because the meat here determined the maximum amount of sandwiches we could make. So this case, the meat is the limiting factor. And since there was 3 slices of meat and it's a 1-to-1 ratio between the meat and the sandwich, we get a maximum amount of sandwiches of 3. Not 4. The cheese is, notice we have some leftovers, so that will be excess. And the bread is also leftover, and this is what we call our excess. And so the meat here would be called our limiting factor. So how do we approach a question like this? So let me give you an example here. In a chemical reaction, 2.65 grams of HCl was reacted with 1.21 grams of zinc, according to the following equation. Which reaction is in excess? How many moles will be produced? And how much excess will remain after the reaction is complete? Now, what I'm going to do is I'm going to do the first 2 questions, A and B, together. Okay, so what's the first step? Just like in the previous question, we would have HCl plus zinc would give you zinc chloride. And the first step that we would do is we would balance the equation. So we have 2 HCl here. Okay, and then the setup is very similar to what we had done before. So here would be 2.65 grams of HCl, and we have 1.21 grams of zinc, and they want to find the number of moles of zinc chloride. Now, if you take a look at the setup, it's very similar to what I had done in the previous questions. If you take a look here, I set everything up. So far, there's nothing new. But where is the difference? So now what we do is we take each chemical. So we take zinc, and calculate zinc chloride. So what we would do is we would go, okay, 1.21 grams of zinc times, was it 1 mole of zinc chloride divided by zinc chloride, which is, let me see, zinc is 65.4. So here we go, 65.4. Okay. And then you multiply it by 1 mole of zinc chloride all over 1 mole of zinc. So we cancel these out, moles, moles, moles. And what we get is, let me see, so 1 divided by 65.4. So I get an answer of 0.0153 of zinc chloride. So I'll pick the moles here. Now, what we do now is we do the exact same thing, but instead of taking zinc, we now take our other chemical, in this case, take HCl and calculate zinc chloride. So you do the exact same thing. So here would be 2.65 grams of HCl times, again, you change it to moles, over 36.5 grams. I'll put grams up here. And you multiply it by 1 zinc chloride over 2 hydrochloric acid. So 2.65 divided by 36.5, and then divided by 2. So in this case, you would have 0.0363 moles of zinc chloride. So what's the significance of this? So now you have 2 possible moles of zinc chloride produced. One that's 0.0153 and the other is 0.0363. So here in this case, because zinc produces the least amount of zinc chloride, therefore zinc is limiting. Okay. Now, do I have it? Yeah. If zinc is limiting, then what happens is, therefore, HCl is excess. So if zinc is limiting, HCl is in excess. And the reason why zinc is limiting is because it produced the least amount of products. So just like if we looked at the sandwiches here, because the meat produced the least amount of sandwiches, the meat would be considered the limiting factor. Now, in this case, if we look back here, if I say, well, how did we calculate the leftovers for bread? How do you calculate the leftovers for the cheese? Now, most of you can probably know this off the top of your head, but are you able to verbalize it? For example, if I were to say, well, for 3 slices of meat, I need 6 slices of bread because of the 1:2 ratio. So 3 slices of meat uses up 6 slices of bread. Since I was given 8 slices originally, 8 minus 6 would give me 3. And that's the same mindset as what you have here. So if I were to answer question number C, how much excess would remain? So in this case, if I were to answer C, so say to calculate how much excess, what you would do is you would take the limiting and in this case, it's zinc, and calculate excess used. In this case, it is HCl. So how would I do that? So I start off with my zinc again because that's my limiting. So in this particular case, I take the 1.21 grams of zinc. I change it into moles, so 1 mole over 65.4 grams times my mole ratio, which is 2 HCl, all over 1 zinc, times my molar mass of HCl, which is 36.5 grams of HCl, all over 1 mole. And then what I do is if I do that, 1.21 divided by 65.4 times 2 times 36.5 grams, that would give me an answer of 1.35 grams of HCl used. Now, to calculate the excess, what I would do is I would take my amount, in this case, my 2.65. So I would take the 2.65 grams of HCl, which is given, and I would subtract it from the 1.35 grams of HCl, which was used up. And that would give me an answer of 1.30 grams of HCl in excess. Okay, so just like the sandwich that we did, you calculated, if I were to flip this back on, using the meat, the limiting factor, which is the meat, and the mole ratio up here, you were able to calculate how much bread you were to use up. And in this case, it would be 6, and then you subtracted 6 from 8 to give you the answer of 2. And that's what we did here. We did the exact same thing. We took the amount of zinc, which is my limiting, calculated how much hydrochloric acid would be used up, and then I would subtract the 2. Okay? So that is how you would do something called the limiting factor. So this first half, I answered A and B together, and then I answered C. Now, for some of you, you might say, well, Mr. Chan, you asked for how many moles of zinc would be produced. How many moles of zinc chloride will be produced? What if I asked for grams or concentration or something like that? Well, once you find the number of moles here, you go back to what we had talked about at the very beginning, and then you can use the appropriate values to either find the ending mass or the ending volume or the ending molarity and so on. Okay. Now, one final thing is this. A couple of things about stoichiometry. Percent purity. We have assumed that all the chemicals we have used are 100% pure, but in reality, that is not the case. So if we have a sample of impure chemical containing a certain amount of pure chemical we're interested in, we can define the percent purity of a sample as percent purity is equal to mass of pure chemical divided by mass of impure chemical and multiplied by 100%. Now, let's say, for example, here, it says hydrogen was made by the reaction 2 sodiums plus water gives you 2 hydroxides and hydrogen gas. If we react 5 grams of sodium, which is 90% pure, how many moles of hydrogen can we produce? Now, the key thing you might want to focus on is this. It says 5 grams of sodium, which is 90% pure. So what that means is, instead of 5 grams, we can only really consider 4.5 grams of sodium for our calculations. All right, the reason why 90% of 5 is 4.5. So if we were to set this up, so we had 2Na plus 2H2O gives you 2 sodium hydroxides and H2. If we were to set this up like how we've done before, I would go with 4.5 grams. And then we would calculate how many moles. Okay. The last thing I want to talk about is this percent yield. Okay, and it's already been done here for you, so you can take a look. It says in most stoichiometric problems, 100% yield is assumed. But in lab work, 100% yield is impossible. The yield from lab work is called actual yield, and the yield from calculations is called the theoretical yield. Now, so percent yield would be like actual yield divided by theoretical yield. This is like your test percentage. So let's say you were to write a test. The test was out of 30. That would be their theoretical yield. The actual yield would be you actually writing the test, getting 27 out of 30. You take the 27 divided by 30, you would get 90%. That would be like your percent yield. And the reason why you have why you don't get 100% is because sometimes there's going to be error. Just like when you bake, sometimes the recipe says you make 12 cookies, but sometimes the cookies might be bigger, might be smaller. You might get less cookies. You might not be able to scoop everything out of the mixing bowl. So there's always going to be some sort of error. Now, let me give you an example here. So what you have is bromine was made according to the reaction. If 10 grams of bromine was reacted with an excess of HBr and 26.3 grams of bromine was produced, what is the percentage yield of the reaction? Now, when you originally set this up, you will notice that I give you both the reactants, which is 10 grams, and some products, which is 26.3 grams. In the situation where we give you both the reactants and the products, like in this original question, the 26.3 grams of bromine is the actual yield. That is the yield that they actually got doing the lab. So how do you progress with this? Is you take the 10 grams and you calculate the product using stoichiometry, okay? Just like all the other questions we've done before. So what you can do is you can pause it here and see if you are able to calculate 37.2 grams of bromine. Now, the 37.2 grams of bromine, how did you know that? Is because that was what was given in this situation. They want you to find out the bromine. Okay? So what do you do with this 26.3 and the 37.2? Well, you calculate the percent yield. You take the 26.3 divided by the 37.2, which is what you had calculated, and you get an answer of 70.6. All right. Now, this is pretty straightforward. The one thing I wanted you to be aware of before we finish off is notice I said it's excess HBr. The reason why I use the word excess HBr, because then you know that all you need to do is focus on the HBrO3. Now, I could be really tricky, and what I could do is give you an actual value for HBr, and what you would need to do is calculate the limiting factor first before you can do the calculations. But at this point in time, I've told you for this example, I've given you the excess, so you know you only need to focus on one reactant. But if I gave you, let's say, for example, 10 grams of HBrO3 and let's say 6 grams of HBr, both reactants, what you would need to do is calculate the limiting factor first before you can do the percent yield calculations. All right, folks, that is it for the stoichiometry unit. And if you have any questions, feel free to come and see me to get some clarification. Thank you very much. Have a good day. Bye-bye.